And welcome to Cooking with Unity. It's the 20th episode, and the screen you're looking at right now is what I get when I try to go to my Cooking with Unity page on Justin.tv. Maybe they got my email and they're doing some work on it or something, but yeah, it's pretty broken. So I'm recording this offline. And so I'm not going to be able to interact with my audience, which is a shame because I have a friend here. Meet Phil. Actually,
Hello.
Should I go with Phil or should I go with Magma-Lemur?
Nah, Phil's fine.
Phil's fine? Yeah. Okay. Well, this is my friend Phil / Magma-Lemur. And you'd know that if he was in the channel right now, which he's not because the channel is down too.
Yeah, the page I'm looking for is temporarily unavailable.
Anyway, he's a good friend of mine. He's learning Unity himself, and he's doing quite well at it. He's got his first game project going. He's going to be publishing that on the App Store at some point soon.
Hopefully very soon.
And he plays a lot of video games, and he's all-around cool guy. And what he was going to be doing tonight was helping me read questions from you guys, which, as far as this episode is concerned, you guys don't exist tonight. So,
which is really a shame.
Yeah. So we had them all dressed up and nowhere to go. And actually, I don't even remember when I started this. I guess it was around 9:15. So I'll end this around 10:15. And let's get started. Oh, one advantage of recording offline is look at the quality. I hope that the quality is still there when I transcode this, but yeah, I think it will be. All right. So when we last left our heroes, or on the last episode of Cooking with Unity Z, or however we want to go around with this, we had a ship, and we have a little enemy ship, and it's horrible and shoots at us mercilessly. And I'm going to actually move him further away from my player because he's being a bastard. And so, yeah, somewhere around there. Alright, now he's not going to kill... Oh, he still got me with his first shot. This game's hard. Games are hard. Alright. So we have this, and we have shooting, and he probably will just wander off screen, and that sucks because things don't wrap. So we're going to add the classic screen wrap to this game, and we're going to do it in kind of an interesting little way. So first off, we're going to do the simplest case for screen wrapping. So I'm going to create a new C# script, and we're going to call it wrap to screen. And I'm actually going to take off my headset because it's not even plugged in. I'm assuming you guys can hear me. That would be awful if I record this whole thing and the audio's not working, but I'm pretty sure it is. So, wrap to screen. Use this for initialization. Update is called once per frame. Okay, so what we're going to be doing here is we're going to be teleporting things that reach the edge of the screen to the other edge of the screen. So we're going to have a couple of variables, maybe. Yeah, we're going to, although no public variables. So this is just going to wrap whatever is attached to it to the screen. So private, how do we want to do this? Yeah, private, how did I set this up when I was doing this in practice runs? And yes, I actually did a practice run this time. Alright, we'll do a vector 3 horizontal edge, horizontal offset. Private vector 3 vertical offset. Private vector 3 actually private float horizontal edge and private float vertical edge. So what these variables are going to contain is descriptions for the screen space that we're working in. And we'll be checking against these variables to see if the object should be teleported to the other side of the screen. So first, we need to get these offsets. So what the offsets are going to represent is just a vector that describes how far away, how far you have to move from one side of the screen to the other. and same with the vertical. And the edges are actually just going to be a float that represents the numeric. I could probably get away with just doing the vectors, but I like having both there because it makes it a little bit more readable. So let's go with figuring out the horizontal offset first. So we want horizontal offset, and I totally misspelled that. Horizontal offset. Did I misspell it the first time? All of a sudden, horizontal doesn't look like a real word. I hate it when that happens. So, horizontal offset equals... actually, let's figure out the edges first. That'll be a little bit easier, I think. I don't know. No. Maybe. We're going to be using screen... No. Man... It's amazing. It's only an hour later than I normally broadcast, and evidently my brain turns to jelly about this time. So, let's use the internet. Unity, viewport to screen. Camera.viewport to screen point. Okay, there we go. So, camera.main. Viewport to screen point. There we go. And this returns a vector, right? Yeah. So we're going to do horizontal offset equals camera.main.viewport to screen point. And, okay, so first I'm going to explain this function a little bit. Viewport to screen point. We've done, what's the equivalent one? We've used a couple of these before, but not this one. Where is it? There it is. So we've done screen to world point, and we've done world to screen point before. And those take x, y coordinates in the pixel space and convert them into world space or vice versa. So what this is actually doing... Oh, and actually we don't want viewport to screen point. We want viewpoint to world point. Viewport to world point. So what this does is it takes a position described in viewport space, where the lower left-hand side of the screen is 0, 0, and the upper right-hand corner of the screen is 1, 1. And so we can describe the right edge of the screen simply by 1.0 and 0.5. So that's what we're going to do. So we're going to do new vector 3. So we want 1.0 f. Actually, does this one just support? No, of course it doesn't. Yeah, what we were doing before. New vector 3, and we want 1.0 f. This represents the right side of the screen. 0.5 f, and I don't think. Oh yeah, this does matter. We're going to have it be how far away the camera is from our main play area. So negative camera dot main dot transform dot z. The reason we're doing that is because our gameplay happens at 0, 0. And I'm making an assumption with this code, by the way, tonight. The assumption is that our camera is at 0, 0, x and y. The z can be adjusted to anything. We're gonna take z into account. But if we had the camera rotated in any way, this will totally not work. But it's not rotated, and everything's happening in the 0, 0 space, so this should be just fine. And it's highlighted. There's a problem. That's because there's not enough of these bracket things. All right. I mean, not braces, not parentheses, parens. All right. So we're gonna do the same thing with the vertical offset, except for we're switching the. Actually, I'll just gotta copy this whole thing, and we're going to set this one to 0.5 f and 1.0 f. And then we determine the horizontal edge. This one is just going to represent the x value. So it's horizontal offset dot, or horizontal offset dot x. And we're going to do the same thing for vertical edge. That equals vertical offset dot y. So now we're going to check to see. So this is figure out the screen bounds, and then we're going to check to see if the object has exceeded the screen bounds. We're doing a lot of typing here before we're actually testing, but this is one of those ones where there's not a whole lot we can test as we go. So, that being said, I mean, like, if you were working this out yourself, maybe just work with one edge and just make sure that it works on the edge that you think. And when you test it, check all your edges. Because I've been in a situation before where I'm like, oh, this test case didn't work, and it totally did work, I just had my math wrong. And you can find that out very easily by just actually checking your work. Just hit everything. So we're going to see if transform dot position dot x is greater than horizontal edge. Transform dot position dot x. Actually, sorry, transform dot position plus equals, no, minus equals horizontal offset. So this is the reason we set up the vectors in the first place. This is just a little bit of vector math. This moves our position one screen to the left. Hopefully. I may have this wrong, but we'll find out. So we're just going to duplicate this a few times. If. Technically, I'm going to go ahead and do else if on these ones because you shouldn't be able to do both at the same time. You shouldn't be able to be on one side of the screen and the other side of the screen at the same time. So it's pretty safe to do an else if in that case. It doesn't really save us anything, but it's technically right. So if it's less than negative horizontal edge, then we add horizontal offset. And then we do the same thing with the y. As a matter of fact, I'm going to just copy and paste this block again just so I can be sure. And then we do y, and we switch this to vertical edge, vertical offset, vertical edge, vertical offset. And we hit save, and I'm going to attach this to our player to start here so that we see if this works. Oh, does not contain a definition for z. Oh, missed a position. Dot position dot z and dot position dot z. And we probably have other ones. Nope, that's working. Although I didn't actually attach it to my ship yet. So I'm going to attach it to the player ship. Make sure it's only attached once. Yes, it is. All right. And hopefully, when we fly around, we will pop to the other side. Oh, okay, my math is a little bit off. Not bad, though. So you can see I'm actually popping to the center of the screen when I wrap right now. So yeah, let's look at our stuff here. So let's actually make sure going downwards does the same thing and left goes the same way too, just so that we can kill any other bugs that we might have. Haha, that ship killed itself. Oh, I killed myself. Forgot that I'm going to teleport into the middle of the screen, right where all the asteroids are. Alright. So, what am I doing? Oh, I just realized you can't watch me on this monitor because we aren't recording it the way that we were doing it before. Oh well.
Correct. Okay, I'll just be a silent protagonist.
Alright, sounds good. Better than being a silent antagonist.
Yeah, no one likes a silent antagonist because no one knows what they're angry about.
Yeah, exactly. So, wrap to screen. Let's look at our code here. So, we can probably pretty safely just put a ×2 in there, although I swear I set this up where I didn't have to do that last time. Huh. Oh, I know how I set this up last time. Yeah, I did 1.5, 1.5, and then I actually did these as separate, didn't I? So these were 1.0, and then dot x or dot y. Same thing here, except for reverse it. 1.0 and 0.5. Actually, when I did this at home, I set this up in the opposite order. I actually did the screen wrapping first, and so I'd kind of figured out the math on that. And so when I copied and pasted here, it made sense, and I had to make some changes. But let's see if this actually fixes our problem. And then I'll try and explain. Oh, yeah, that caused a problem. Definitely messed something up. Oh, 2.y's. We want a .x here. Phil is keeping up with this, and he's not even seeing the screen. Like, I can totally tell he's like, oh, I know what happened there. It's just like, I've been there.
Yep. All too many times.
Yeah, you copy and paste, and you need to change all the variables. So now it should pop nicely. Yes, it did. All right. Perfect. So we're wrapping. Now, nothing else is wrapping, but we can fix that very quickly. All we have to do is just apply this to all of our prefabs and to our enemy ship that is ironically not a prefab, which we probably will alleviate that at some point. But now, if you shoot, you should see the bullets come out the other side, and so we have basic wrapping already working, and it's only been 15 minutes, so that's great. So let's go back and look at the code for a moment and see what we're actually doing here. So what these things mean, this big old block of code here, is we want viewport to world point. Now, the reason I did 1.5 is because does it even make sense in this particular context? It'll make more sense when I do the wrap setup. But basically, we're moving. That's the screen plus half a screen, and so if you subtract that from, all of a sudden it doesn't make any sense to me, but it's working. So this represents a point in the middle of. Okay, that makes sense. Yeah, it represents a point in the middle of the next screen, and so we are moving our point back a screen and a half? That doesn't make any sense. Huh. It's working. Where I'd come up with this originally was when I was doing the camera wrapping. I'll just show you that. So maybe this, maybe I've just set this up in a way that doesn't actually make logical sense, because the way I had come to these conclusions were something that made logical sense in another case, and they just happened to work in this case. But it's working, so I'm not going to complain. But basically, we're getting the vectors to change our position. We're doing plus equals and minus equals here for the reason that if you overshoot by an excessive amount, you'll overshoot by that much when you teleport to the opposite side. And all these are doing are just checking bounds checks. Like if you're outside the right edge of the screen, if you're outside the left edge of the screen, if you're outside the top of the screen, or if you're outside the bottom of the screen, you just add that offset to your position, and then it solves the problem. So let's go and do the next step. So this works, and honestly, you could release this, and, well, other than the graphics, well, actually, you could probably release it with these graphics too, but you could release this, and most people wouldn't even complain, because you do actually wrap, and you shoot things, and they show up on the other side of the screen, and the asteroids are wrapping, and everything kind of works pretty cool. Except for the fact that when you get halfway outside of the screen, you don't see yourself on the other part. You just pop. And that gets my goat. And it probably shouldn't, but it does. So the original Asteroids game totally does a smooth wrap. And the way they do it is more interesting because of how old that game is. But because we're not in old game days anymore, we can do some very fancy ways to do that. So one of the ways that you could do it, potentially, is to have at least 4 objects in addition to your player object. Well, at least 3 objects in addition to your player object. So when you were on the edge of the screen, you could spawn in another player and show them at the bottom of the screen there at the same time, and just have them rotate the same way. And that's one way of tricking it. And then when you're at the corners, it would be 3 as the maximum. And you could even simplify it and not spawn them and just do 8 around the player, so that each object represents 8 objects, and then the additional objects are set up in such a way that they come into the screen at the same time that you exit it. We're going to do it slightly differently so that we don't have to create a whole bunch of each object. We're going to actually set up 8 additional cameras and render them on top of the scene, and we're going to organize the cameras so they are at the edges of our current camera. I'm going to show you one camera first, and then we'll move on from there. So we're going to do this programmatically. Actually, we're not going to do it first. I'm going to show you it first. So we're going to duplicate the main camera, and we're going to call this a wrap camera. And we're going to change a few settings on this. First of all, we don't want it to be tagged with main camera because we don't want our calculations to occasionally grab the wrap camera. We need the field of view, clipping planes, normalized viewport rect, all that needs to be exactly the same as our main camera. Otherwise, the illusion will be broken. So we have this wrap camera. This one is identical to our camera in every way except for it's not tagged. And we're going to change one more thing. We're going to change the depth to 0. So it should render after the main camera. Let's see that description. Camera with a larger depth is drawn on top of a camera with a smaller depth. Perfect. And we're going to get rid of the clear flags. We're not going to clear anything. And what this means is this will render as well as the main camera. Oh yeah, and we're also going to get rid of this audio listener, this flare layer, and this GUI layer, because we don't need any of that. So, and as a matter of fact, the audio listener will give you a little message that says you should not have more than one audio listener in a scene. And so this fixes that right away. So if I hit play, it'll actually look just like it used to. Like, things have not changed. Now, the reason it looks this way, let's actually start playing, and I'm going to pause it here. And we're going to move our wrap camera a little bit to the right. And if I unpause, you'll see that there are now 2 of everything on the screen. So we're rendering, the left one is the real deal, and then the right one is this additional camera that is looking at our scene from a slightly different angle. Now, in theory, if we adjust the cameras just right, I'm going to move this one to the right, teleport to the right. And I'm going to hit play again. Now, if I move over to the right side of the screen, you should see there I come in on the left. So it's still not perfect, but you can understand the concept here. If I was to get it perfect, it would look like I just came in on the left side of the screen. So the trick with doing this is you'd have to make it perfect, which would require a lot of trial and error. Or you could use a little bit of math and do it programmatically, which is how we're going to handle it. So first of all, I'm going to actually create a prefab of this wrap camera, because that'll make it easier for us to instantiate them. And this already has all the settings that we need, other than the appropriate position. So now what we're going to do is create a new C# script called create wrap cameras. So all this is going to have is a start function. We're not going to handle... There is a special case where we would need to readjust the boundaries and readjust the cameras, and that is if you resize the play area while it's playing. I'll show you that bug. We're not going to address that in this episode. It would be easy enough to do so. You could basically just detect if the screen resolution has changed and then redo the steps that we're going to do in start. But we're just going to do this right now in the start function and not worry about the future stuff. You can handle doing the rest on your own if you need to have it dynamically resized for some reason. So what we're going to do is I'm going to go ahead and grab the horizontal offset and vertical offset functions. Not functions, variables. I'm just going to do this. And actually we're going to set them the exact same way. We only care about the vectors in this case because we're not going to be doing any edge testing. We're just going to be offsetting the cameras, and offsetting is very easy using vectors. So here we go. We're going to figure out the screen bounds. And so here I'm going to explain why we're doing 1.5. Like, I couldn't actually justify it before, but I'm going to justify it here. We want the cameras to be offset not so that they're centered with the edge. We need them to be centered with... They need to be one whole camera thing over. And so 1.0 would put them right on the edge. We need to move them another half camera away to be centered properly so that they do not overlap the main camera area at all. So that's what this 1.5F represents. It means edge of the screen plus half a screen. And we're doing the same thing for the vertical. And the reason we do the 0.5 is so that our vector comes out as a horizontal or vertical vector. Technically, we could make that anything and then just isolate it to be a horizontal or vertical vector. But that's extra lines, and we don't need to do that. So we're just using 0.5 so that it's right in the center and pointed right to the edge. And we only need a horizontal offset and vertical offset because we can use this in different combinations, as you'll see below, once we start instantiating stuff, to get all the positions that we need. I'm going to add one more private variable here, actually. We're going to do the camera Z offset. Vector 3, camera Z offset. Actually, I'm just going to call it Z offset to be appropriate with the rest of these things. And this is just going to be simply Z offset equals camera.main.transform.position.z, although we want it to actually be a vector, so new vector 3. Alright, I'm going to show you how we normally do this on the show, and I'm also going to show you another shorthand for this one that uses some vector properties. So we want X we don't care about, so 0. Y we don't care about, 0. And then camera main transform position.z. So this will be our negative 30. That's where our camera's currently put. And we're basically just going to add this in when we set the position of the camera so that it is in the same line as the camera. Now, we could have actually done this a slightly different way. We could have done Z offset equals camera.main.transform.position.z and then multiply it by what is it? Vector 3 dot forward. And this actually will result in the exact same thing. The reason being is this is a scalar. This is just a float. And we're multiplying it by a unit vector. Vector 3 forward is a unit vector forward. And since this results in negative 30, it would make basically it would make a vector pointing backwards 30 units. And honestly, not saving much typing time. Technically, though, we're saving a little tiny bit of memory with this line, just because instead of operating on creating a new container here for a vector, we are actually just giving it one that already exists. I'm just going to keep the... I'm going to go ahead and just comment this one out. Fancy pants way of doing things. I'm going to keep it the old way just because it's a little bit more readable, I think, honestly. But you will, if you read other people's code that are doing this stuff, you will probably run into that notation occasionally. So, especially if you start looking at other game platforms and stuff, like you see this kind of vector math done all the time in Half-Life 2 if you've ever done any mod work for the Half-Life 2 engine. So, what are we doing? I'm sure that most game platforms are that way, but yeah. So we have our positions. Now we just need to actually set up our cameras. So we're going to instantiate some cameras. Oh yeah, we're going to need a public variable. Public game object wrap camera. I'm just going to call it wrap cam. So this represents our camera that we're going to be instantiating. So we're going to instantiate our cameras at the proper position. So instantiate wrap cam. Now the position is going to be based on our transform position, so we're going to start with that. Transform dot position. Actually, if we're basing it on transform position, I don't see why we even need that z offset. We may not even need that z offset, but so transform dot position would be right where our camera is. This one we're going to do the camera that goes to on the right side of the screen first, just to test this thing, and then we'll do the rest of them. So that should just be transform dot position plus horizontal offset. And then for our rotation, we're going to use wrapcam dot transform dot rotation. So pretty simple line, and actually this is probably less lines of code than you thought you were going to need to do true screen wrapping. It certainly was when I was testing it out. I thought it was simpler than I thought it was going to be. So here we go. We go to the edge of the screen, and nothing happened because I didn't actually attach this to anything. So we're going to put, where is it? Create wrap cameras. We're going to attach this to our main camera, and we are going to attach a wrap camera to the wrap cam. So we hit play, and hopefully when we get to the edge of the screen, you should see half the ship go to the other edge. And it totally worked. So as you can see, as I get across the threshold, it pops on this screen because there's no camera on the left to handle the that transition. But you can see it's actually, you can see it just smoothly come in from the edge there on the right hand side at least. So now all we have to do is just do the other 7 cameras. So that's super simple. We're just going to copy and paste this another 4 times and another 4 times. I like to do it kind of grouped because we're going to do the side cameras, and then we're going to do the corner cameras. So we've got the one plus horizontal offset. Left side of the screen is minus horizontal offset. Top portion of the screen is plus vertical offset. And bottom portion of the screen is minus vertical offset. Now, if we hit save, we're creating a few extra cameras right now because I haven't commented those out, but it isn't going to hurt anything. We should see it working in all cases except for the corner case. So like if we go up here, we smoothly transition, excellent. And you can see that the asteroids are smoothly transitioning now. And if we go to the right-hand side of the screen, we smoothly transition. And if we go to the left-hand side of the screen, we smoothly transition. All that works. So now there is this corner case, where if we go to a corner, it works a little bit, but it... Actually, maybe it works all the way? No. Yeah, you don't see yourself on every corner. It's just not quite perfect. You'll see a little bit pop in at the corner. Again, we could probably get away with not having that fixed, but I'm fixing it because it's super easy to fix. So now we need the corner. So the top right corner would be plus horizontal offset and then just plus vertical offset. So this is now two vectors, one pointing directly right to the edge of the screen and one pointing directly up to the edge of the screen. When you add them together, you go up and then right, and then you end up at that wonderful little corner. So same deal for the... So bottom corner is minus vertical offset. And then we can do minus horizontal offset in both these cases, and plus vertical offset and minus vertical offset. So basically just every combination of those two that we can do with pluses and negatives. And this should work 100% then. So now, God, that enemy's a terrible thing. Come on, crash into something. No! Stop living! You're a horrible thing! Asteroids are going everywhere. Alright, I'm going to have to kill him. Oh, wait. Asteroid got him. Good. So, if we get to this nice corner case, we should see all four corners. Yep, you can actually see at the lower left and the lower right and the upper left, we transition smoothly. So, now we have working wrap. Now, I mentioned that if you resize the screen, it will screw things up. So it's true. If you resize the screen smaller, and that's... Okay, so if I hit play, it actually works, because it, at the very start, it sets everything up properly. I'm disabling that stupid little ship. Hold on. Keeps kicking my butt. So, it's working, it's working, it's working. Everything's great. And then if we were to extend the monitor a little bit, oh, we can see ourselves early. It's kind of cool, actually, because it's technically valid. Everything... Oh, wait, no, it's not technically valid. Why are my bullets not killing these things? Oh, because I wasn't actually there. Yeah, so it's not valid. Because you're teleporting in at about this point, and so I'm not actually on the left side of the screen anymore, even though it looks like I am. So it doesn't work exactly right. But if we hit stop and hit play again, it's fixed. As I said, you can check to see if the screen width and screen height have changed. Well, rather screen width or screen height have changed, and then just readjust it. As we have 15 minutes, actually 20 minutes, I think. Why don't we just actually fix that so that you understand how to get this set up? So first off, I'm going to do a little bit of organization on this project because we're almost at the point where all of these things don't fit on my screen anymore. So I'm just creating a scripts folder, putting all our scripts in there. And then let's create a prefabs folder and drag it outside of the scripts because it wanted to go in there for some reason. Throw all those in here. And I'm going to go ahead and create a... Well, I'm going to enable it first. Maybe. And create a prefab of the enemy ship. We really should have had that earlier. I don't know why I didn't do that, but there we go. There's a prefab now. And I'm going to just zero out the position on the prefab because I am OCD like that. And I'm just going to disable our enemy ship again. And we're going to see about adding this functionality. So, right now, we're going to have to change it in... What happened to... Huh. Alright. Let's look at wrap to screen. So, we're going to have to fix wrap to screen to change, and we're going to also have to fix create wrap cameras. Oh, create wrap cameras. Yeah, that'll work. Maybe. Alright, so since we're instantiating the cameras, since they don't exist ahead of time, what I'm actually going to do is we're going to have to destroy all of them. So an easy way to do that is we're going to take our wrap camera and we're going to add a tag to it. I'm just going to create a new thing called wrap camera. And then we're going to actually put the wrap camera in here because we're going to need to be able to destroy all the old ones. Otherwise, we'll just, every time that the window resizes, we'll be creating new ones and they won't ever get destroyed. So I'm going to add a little destroy thing. Destroy any wrap cameras if they exist. So we're going to do for each game object cam in game object dot find game objects with tag plural, and then we put in wrap camera. And we don't need a semicolon there because that's for each statement. And then we just destroy cam. So that cleans it up. If there are no game objects with wrap camera, it won't destroy anything. So this is a completely safe operation. For each statements are great for that respect. In that respect. Now this is all in our start function. So what we're going to do is we're going to actually set up a void. I'm going to call it layout cameras. Actually, I'm just going to say create wrap cameras. And why is this giving me an error? That has a return type of, yeah, I know it has a return type of void. Oh, it's named the same thing as our function. Okay, let's just call it, let's do what we did before, layout cameras. And we're going to just copy and paste this whole chunk of code and put it into layout cameras. And then we're going to add layout cameras to our start function. So this should do exactly what it did before. So we're going to just quickly test it right now, just to make sure that we didn't break anything. And lo and behold, everything is working just as we want it. Now, all we did was move this stuff into a function and then call that function. How does that help us? So here's how it helps us. We can now call this function when the screen resolution changes. So there's no callback or anything for screen resolution changes, so we have to manually check this. So we're just going to do void update. And in our update loop, we're going to check to see if the screen resolution has changed. So we're going to need a couple more private variables here. Private, what are we checking? If the screen resolution has changed. Okay, so private float screen, actually, private int screen width, private int screen height. And actually, that's not a proper variable name for this. It would be old screen width and old screen height. So first, in our start function, we're going to set old screen width equal to our screen width. So that would be screen. Is it screen? Yeah, screen dot width. Wow, that was easy. I was expecting to have to type more dots. Old screen height equals screen dot height. In our update loop, all we do is if old screen width does not equal screen dot height, or old screen height. Sorry, I just made a major mistake there. Width. Or old screen height does not equal screen dot height. So what this means is, technically, we've set old screen width to be the screen width and old screen height to be the screen height. If the screen resolution is changed on a frame, screen width will no longer be equal to our old screen width, because that's only set once. So in this case, we want to run layout cameras, and actually this is a perfect case. I'm going to actually put the old screen width and height stuff in the layout cameras so that we don't have to worry about duplicating that code anywhere. So we'll just put that right at the top. Save current res information. So now if we hit play and we move the screen in, it should totally work. And it does. So that's awesome. So no matter what happens... Oh, wait, no, I didn't collide with that. That's scary. Okay, so it is... Oh! Okay. I see what happened. So yeah, we actually did fix the camera thing. And actually, I wanted to show you the scene while it's running when we adjust the screen space. Oh, okay, so I'm going to move our game over to a separate thing. And if you watch the wrap cameras, they will actually adjust their values. Maybe. They're going to make liars out of me, I think. Oh, I see. It destroyed them. That's right. We're not changing their values. We're just straight up killing them every time. So that's the reason I can't actually see them in the inspector. But they actually are being created and destroyed. So like if I move back, you'll actually see the camera positions. And if I change it, you'll see them slightly different. Okay. So not a great test, actually, visually, but you get the idea. Now, the reason that we're having a problem has nothing to do with what we just did. It would be very easy to make that mistake, though, and I want to point that out. Is like there's a lot of times when you'll be working on code and you'll be hitting your head against a wall like for an hour, 2 hours, 3 hours, a week. I've been there a month once before. And then you find out that it wasn't at all in the code that you were looking at. So our problem is our wrap to screen needs to be set up in the exact same way. But it's not. Our wrap to screen stuff is static, but our create wrap cameras is dynamic. So we're going to do the same thing. We're going to create these little private ints. And then we're going to add the functionality to find out what they are. And throw that into... We're just going to throw it in the start thing as a work area for right now. And then finally, we're going to just copy this update loop verbatim. Oh, no, we're not, because we already have an update loop. So we're going to copy the middle of this update loop verbatim. And layout cameras is not exactly right, so we're going to call this one get screen bounds. That's what I'm going to call it. That's accurate enough to what we're doing. We're going to change this to get screen bounds, and then we're going to call get screen bounds here. And we're going to copy all this wonderful code from start and throw it into get screen bounds. We're going to hit save, hit play, and so we're going to check the static case. Looks like things are working. Looks like I'm teleporting nicely. And then we're going to change the edge value. And it looks like things are working. And let's see if I collide properly on the left side of the screen. That was our test case for before, and I do. So now everything works exactly the way we want it, and it supports dynamic resolutions. Also, we are doing a check for the resolution every frame. We could probably make that less constant. But all we're doing is just getting the screen width and height and comparing it to an old one. It's not costing us a lot of CPU time. That being said, we are doing that per object in the case of wrap to screen. So one optimization we could do is we could make that more periodic. And another thing, but that being said, this is much better than just the brute force. We could honestly do the whole calculation for the horizontal offset, horizontal edge, vertical edge, every frame. And honestly, if I put that in there, it would probably run just fine on my computer. But that's the kind of logic that if you are running that on a portable platform, you're going to run into performance bottlenecks real quick. So, oh yeah, I can do some editing and post on this video because it's not live. So I'm going to pretend that there's text on the screen right now. Go ahead and email me at pushypixels@pushypixels.com. I hope that there will be text on the screen when I'm done with it, but if not, just listen to the words that are coming out of my mouth. And if you like cooking with Unity or you like breakout games, grab Proton Pulse on the App Store and support the show, support my little indie project called Pushy Pixels, and thank you very much, and good night.
Good night.
Good night, Phil.
Good night, Max.